Making the web accessible relies on Semantic HTML. Instead of only focusing on how the UI looks, think about what the UI means. I'm Ross. I'm a director of CanAccess, a digital accessibility company based in Canberra. We work with lots of interesting teams around the world, helping them with accessibility audits, design reviews, WCAG conformance, and everything accessibility related in between. If you're interested in working together and making accessibility a tangible outcome for your digital projects, reach out to us at hello@canaccess.com.au. That's CANAXESS.com.au. Choosing Semantic HTML means the UI becomes multimodal, consumable in more places, and most importantly, accessible for more users with more diverse disabilities. The Australian Signals Directorate is Australia's intelligence gathering organisation. Think of it as the US's NSA or the UK's GCHQ. They're the ones breaking codes, listening to and collecting intelligence, protecting the country from threats far and wide. They've been around for 75 years, and 2 years ago, in recognition of their founding, they produced a commemorative 50-cent coin. Now, for a code-breaking organisation, you'd expect it wasn't some boring logo on a coin. Instead, the coin had several features and codes embedded on both sides. On the reverse side featured letters on the outer and inner ring, some embossed to make them stand out, whilst in the middle were 3 sections with the lower featuring letters and numbers. Whilst on the front of the coin, braille lettering is beneath several letters of the words Elizabeth and Australia. The coin has an accompanying webpage which describes the image, but it's incredibly challenging to describe if you can't see the image. For people who are blind, describing images on the web comes down to using and relying on other mechanisms to understand the image. These users use a screen reader, which is a piece of assistive technology software that describes the image in an audible way. But the way the image is marked up in HTML can mean it's either very easy to understand or very hard. Navigating with a screen reader means how the content is displayed becomes less relevant. When the ability to see content on the web is reduced or removed, the screen reader attempts to make use of other mechanisms. It may use the alt attribute on the image, an ARIA label attribute, or the content surrounding the image, such as paragraph text or figure element. Think of this as metadata for the image. For example, on the NVDA screen reader, pressing the keyboard a character G will cycle through all images on a page, and assuming they're correctly marked up, will audibly announce the alt text. But what are some ways to describe this incredibly complex image? Now, we could use alt text, as that provides an alternative text for the image. Perhaps alt a commemorative coin. When the screen reader encounters the image, it would then announce the text commemorative coin. Whilst this alt text is accurate, because it is an image of a commemorative coin after all, it's not exactly helpful or a rich description of what the image conveys, and it isn't providing an equal experience for users who can't see the image. So if you were describing the coin to someone, you would use a rich description. You wouldn't only say commemorative coin. You'd describe its embossing, perhaps the inner and outer rings and circles. And that's what we're wanting to convey. It's a coin and it's an image of a coin, but what's so special about the coin? When providing alt text for images, we need to provide just enough detail as if you were describing it to someone. I could therefore use alt. Letters rotating around the edge of the coin, VKG, are emphasized. The reverse of the coin is segmented into 3 with the letters E3, B8, 287, D4, 290, F7, 23381, 4D7A4, and you get the picture. But this quickly descends into a nightmarish approach of attempting to provide so much information that the alt text is no longer a viable method to describe the complexity of the image. I pity the person trying to understand the alt text of such depth and such detail. We could use adjacent paragraph text, but once again, we're using text to describe the visual changes of the text. The description, which is understood visually, is becoming diluted with unnecessary text, taking away the meaning of the image. A way to describe the meaning of differences in text and placement without using text and overloading the user is required, and that way is Semantic HTML. Semantic HTML is the backbone of an accessible web. What this means is when HTML elements are used to describe the meaning of the content, that content can then be interpreted in ways not necessarily text-based. Semantic HTML provides a backbone which describes the meaning of content. Semantic HTML may introduce a different sound in the screen reader, be consumed in non-visual ways, or otherwise alert the user that this bit of Semantic HTML content is different, and so describe it differently. When semantic HTML elements such as headings, lists and form elements are used, they provide extra features for the screen reader for free. When navigating headings with a screen reader, pressing the H and Shift H key cycles forwards and backwards through heading levels, announcing the heading text and level.
Heading level 1 heading. Heading number 3 heading level 3. Heading number 2 heading level 2. Heading level 1.
When navigating lists, pressing the letter I on the keyboard announces the number of items in the list as well as individual items. In this example, I can cycle through each list element and I hear the list value, the fruit, and that it's a bullet item.
Bullet bananas. Bullet pears. Bullet bananas. Bullet apples.
Form controls provide extra metadata to be described, such as the type of input required, which in this instance is an edit to control and it's blank. Controls may also make additional sounds to indicate when on a form control. This describes an edit control and its initial state is blank.
Edit blank.
And it's all this metadata richness is what we're wanting to tap into. At the 2023 Microsoft Ability Summit conference, blind Microsoft developer Roberto Perez described intentional audio cues in Visual Studio allow him to understand information faster than just relying on screen reader speech. So if we can rely on non-text ways to describe the content using sounds or other metadata without having to describe it, this sounds like a pretty good outcome. Intentional audio cues are what we're trying to leverage.
I am Roberto Perez, and I've been working in accessibility at Microsoft for a little over a year now. When I'm coding or just using the computer, I use a keyboard with a braille display so I can read what's on the screen and hear speech coming from the screen reader at the same time. There is content which I find easier to understand by listening to it, while numbers, for example, are easier to understand by reading. Audio cues create an additional layer of information I need to listen to. However, intentional audio cues in context are easier and faster to process than screen reader speech once I know what the sounds means. It can be a productivity booster when used properly.
Non-text cues to content means that the content can be understood in different ways. It may be your tactile, audible, or ways in which we haven't yet identified. It's allowing a content to be consumed in multiple ways. Traditionally, a UI was one mode. It was visual, and what we saw is what we got. But building a user interface today and embracing Semantic HTML means thinking of it as a multimodal experience and not just visual. By building a content to describe meaning and giving users the ability to consume the content in any number of ways, it opens up the possibility of supporting more users who access it in ways which are convenient for them. What ASD did to overcome the challenge of describing a complex image was very, very clever. Instead of only providing a lengthy description in alt text or in a separate text, which we know is very, very hard, they used Semantic HTML to enhance meaning to those elements that are visually distinct. What I mean by this is they used HTML to provide meaning to the content. On the Queen's Head side of the coin, content with the letters B, TH of the word Elizabeth, and ASA of the word Australia are contained in the HTML element strong. And this corresponds to the locations where Braille is applied. Whilst on the reverse side, the emphasized letters alternate from being contained in the strong element to not. The outer ring has the letters D, R, F, H, R, M contained in the HTML element strong, and this is the same with the inner ring. Wherever there is a visual emphasis, that emphasis is described with the HTML strong element. Visual emphasis using the strong element and then back to regular text. The HTML specification describes the HTML strong element as representing important, seriousness or urgency in its content. And this is a really great demonstration of importance in those bits of content. When text is visually different, to convey the importance, the strong element is appropriate to use in this situation. Strong, and the element strong is providing that meaning. All this is really good to describe the emphasis of text and word elements, but what about the actual alt text on the image? How did ASD connect the alt text, which is the traditional way to describe images, to the content? They used see the accessible text version below for a detailed description of side A, non-Queen's Head of the coin. Now this is pretty clunky. Asking the user to see the text below, because see, well, not everyone can see text. And see below is referencing a direction which is in violation of the Web Content Accessibility Guidelines, Success Criterion 1.3.3, Sensory Characteristics. Using a direction to describe where further information is will exclude some users who have difficulty with cognitive requests. But at this point, I was thinking that's a pretty good innovative implementation of using Semantic HTML to describe complex visuals in a different and unique way. It's not perfect and has some flaws, but we're not letting perfect be the enemy of good. Overall, it's pretty good, providing the meaning of emphasized text, all without relying on the fallback method of just providing text. How well it's supported in the screen readers JAWS and NVDA, this is where it gets interesting. All screen readers don't support text-level HTML elements. What this means is the strong element is not announced in the screen reader JAWS, Windows Narrator, NVDA, VoiceOver on macOS, and VoiceOver on iOS. No screen readers convey the strong element to users. The screen reader NVDA did support a similar semantic element, M, for emphasis, but then found the element was often overused on websites, and it led to a really poor experience for NVDA screen reader users, and they promptly disabled the screen reader from interpreting it. NVDA said having the emphasis element reported by default has been extremely unpopular with users and resulted in a lot of complaints about NVDA. The unfortunate reality is that emphasis is very much overused in the wild, and this is also applied to the strong element as well. But let's back up a little to explain a little more about how screen readers understand content on the web. Screen readers and other assistive technologies understand the web through reading the accessibility tree. This is a representation of the physical page. It gathers information from the DOM tree and rearranges it into a format that can be understood by assistive technologies. Things like screen readers, eye tracking systems, and speech input software. By using Semantic HTML, this allows the visual content to provide meaning to be consumed in any number of alternate ways, assuming that content is created in the correct way. Although browsers expose the strong element in the accessibility tree, and in theory make the strong element available to assistive technology, the element is in no way supported in all the screen readers tested. Simply put, the strong element is not accessibility supported using current technology. If you were testing your own apps and websites for conformance to the Web Content Accessibility Guidelines, whether content has been created using these elements shouldn't be a factor in determining a pass or fail against Success Criterion 1.3.1 Info and Relationships. Whilst the browser identifies the strong element in the accessibility tree, it's the screen readers which refuse to honour it. Unless, if a visual style accompanies the strong element in some situations, this is announced by the screen reader, with a few caveats. If the strong element is combined with, say, being bold, and if that feature is turned on within the screen reader, they are announced. Visual CSS style changes of bold and italic are well supported across all screen readers on desktop and will be announced to users. But the setting within the screen reader needs to be turned on and activated. If you're relying on a user having to have a setting toggled within their screen reading software for your content to be better understood, it's probably not a good outcome for them. Bold text for formatting purposes can be interpreted by the screen reader to make web content audibly announce those elements in a different way, But as the web is awash with bold content, that too probably won't be effective to describe the meaning of emphasized content. So with all that in mind, what are some other ways that we can use to describe the differences in text without having to describe those differences with text? An emerging development on the web is the CSS speech module, which provides the ability to add emphasis to audible content. The big problem though with screen readers is when they audibly announce a content, there is no nuance with the synthesized voice. The synthesized voice may vary slightly with volume, but the content which is prominent or important is output in exactly the same way as any other content, dull and monotone.
This is really important.
With CSS speech, it would be possible to subtly alter the way the emphasized parts of text are announced by the screen reader, giving the content an oral texture.
This is really important.
Notice the increase in pitch and tempo on the word important. Making the strong element have an oral emphasis signals to the user the text is different and provides an enhanced output for those elements marked up in that way. This is really promising, but as the CSS3 speech module is yet to be ratified and still subject to change, its support is extremely limited across browsers and screen readers. This example is purely hypothetical. Current technology just doesn't provide a consistent, out-of-the-box way to orally identify visual changes in text content. Alt text is insufficient, the strong element isn't accessibility supported, Semantic HTML in many instances is ignored, and the CSS3 speech module is still in draft. What then can be achieved with the current limitations? How can visual changes in HTML be conveyed to a screen reader user? By Semantic HTML and using those elements which provide meaning, such as strong and emphasis. Semantic HTML is the way to describe visual changes, even though it's the support for conveying the text in other ways is currently limited. Semantic HTML allows us to adopt progressive enhancement for when technology catches up. We don't need to do extra work to make the content accessible, as we've already provided the skeleton. If screen readers begin honouring the semantics of the strong element, then it's supported and we don't need to do further work. If the CSS speech module is moved to recommendation by the W3C, then a simple toggle of the CSS means vocal texture is applied. Applying Semantic HTML to describe the differences in text makes progressive enhancement real and tangible, and it makes the content consumable in any other format. Just because it currently isn't supported, it doesn't mean it won't ever be. Semantic HTML is the backbone from where we add extra features when the technology catches up and supports it. So how could a complex image like what ASD had be described in further detail without relying on just the text alone? And how could we improve what's already there with the strong element? There's always a difficulty trying to use linear hierarchies and widgets to describe a complex image, but let's give it a go. We'll use Semantic HTML elements that are supported. We first want to separate the front and the reverse of the coin, and we'll use heading elements. use a H2 element for the front of the coin,
Heading level 2 front of coin.
and one for the rear. By using headings, the information on both sides of the coin is separated, allowing a screen reader user to understand each group.
Heading level 2 rear of coin.
On the rear of the coin are two rings, an inner ring and an outer ring. To describe the number of rings without marking up in the text, we'll use the unordered list element. This element provides additional metadata without us having to do anything.
1.devsivsvoiskstrelfroomslungsfkegsmunfgrixfallfree, tube convoy at cyrilngniagrerxnti of CKO electin refi.
In this example, it's announcing two items independently, but it's combining all the individual characters and attempting to say the entire string as one word. Let's try and improve the individual list item elements with the ARIA label and encourage the screen reader to provide a little bit more context.
1.devsivsvoiskstrelfroomslungsfkegsmunfgrixfallfree, tube convoy at cyrilngniagrerxnti of CKO electin refi.
But it doesn't provide additional context. The ultimate debate and switch. It's ignored the ARIA label on each list item. We've done everything right to enhance the list, but the screen reader isn't honouring those extra attributes. But let's apply this same technique with the inner segments. Each segment being a separate list item which describes, when navigated with a screen reader, a list item X of 3. Whilst we could add more, we're going down that difficult path of adding a lot of techniques to try and describe an image without text. Metadata helps, but it's not providing an adequate experience. So far, the screen reader's output isn't great. We've only marginally improved the grouping of items, yet we will need to add better support for announcing individual letters and not entire words. And the screen reader isn't even honouring the extra labelling. Ultimately, the HTML elements we have at our disposal are limited. Fixing the grouping and arrangement of the text highlights further problems now of how the content is announced. There really is no efficient way to mark up the differences in the text beyond using the text and poorly supported semantic elements. If we build ever more complex relationships with HTML elements, it becomes a lesson in futility, as the effort to build the HTML far outweighs the benefits of just using headings and strong elements to describe the image. The most robust technique is the easiest to build and easiest to not get wrong. There's now a lot of moving parts to the description. Every attempt to use ever more complex elements in ever more complex relationships will mean a friction point with the developer, where extra care and focus needs to be taken to build the image in just the right way, and the likelihood of things breaking or not being created in the right way significantly increases. The best option for describing complex images is the easiest, and that's what ASD chose. As developers, it's often attempting to build in complexity and try and answer problems with layering more and more code on top. And sure, given enough time, a better solution could probably be identified. If you find yourself having to describe the level of complexity in an image similar to ASD's commemorative coin, follow their approach with what they use to describe a complex image. Avoid unnecessary alt text. Provide just enough detail which explains the image. If the image is complex, reference a separate location from where the description can be found, but avoid the directions of left, right, up or down. If the image is that complex, use heading elements to provide a hierarchy and segment a complex description into regions. For grouping of items, use list elements which provide extra detail such as the number of items. And apply semantic HTML elements such as strong, italic and EM emphasis to describe the changes in text. Whilst they're not well supported in screen readers, they do provide the context and progressively for it when technology catches up. It's supported more and more. Build it once, build it right. More often than not though, you won't need to describe complex images with this level of detail. More often than not, you'd only be using the alt text. So all you need to do is make sure the alt text is sufficient. What ASD did was clever. They used semantic HTML to describe visual differences in text content in a way other than text alone, and they layered the content with oral texture. But as we've seen, technology hasn't yet caught up with this really a good example. Other things they could have done are provide a description in the alt text of the image, guiding the user to find more, although the wording is a bit clunky. They used a collapse and expand widget to provide the text shown in the coin. And all this is accessibility in depth, using a range of techniques to enhance access and understanding to the largest possible number of users. Just because the strong and other semantic elements aren't fully supported now, it doesn't mean they won't ever be. But that isn't to say ASD's example cannot be improved. Their use of alt text is clunky. No heading elements are used to segment the two sides of the coin, and there is a significant accessibility defect where the collapse and expand to content has unfortunately been coded incorrectly. ASD's motto is reveal their secrets, protect our own. And it's this last line which unfortunately has been taken too literally. Up to this point, what ASD did was a pretty good attempt to make a complex image more accessible. However, it all comes down to the execution. The contents are contained in an accordion control. It's been built with the several ARIA attributes that convey the visual behavior to a screen reader. When it's expanded, the screen reader announces expanded, collapsed for collapsed, all pretty standard stuff and follows the established patterns for screen reader users.
See the accessible text version greater tab collapsed, expanded, collapsed, expanded.
Except when it comes to the use of this little attribute, ARIA hidden equals true. Every time a panel is toggled, this too should be toggled to allow a screen reader to find the content. Pressing 9 on the number pad should begin reading the next line in the expanded panel, except it doesn't.
Accessible text version greater, expanded. Tab expanded greater. Heading level 2 a brief history of code. Tab collapse substitutions. Tab collapsed greater. Tab collapsed at bash.
Now it bypasses the entire expanded container and instead reads the next heading, then the other collapse expand regions. It completely bypasses the text. It makes it hidden and it makes it invisible to a screen reader user. And this is a big problem. This remains set to true, meaning all the content, no matter what is shown to the user visually, is hidden from the screen reader, rendering the visible content invisible to a screen reader user. The fix, however, is easy, and that's ensuring the value is toggled in line with the showing and the hiding of the content. Altering the code and repeating the navigation again by pressing 9 on the number pad begins reading the next line. One small change has improved the broken accessibility.
Accessible text version expanded. Tab expanded greater. Side B, blank. Eliza BETH2, AU, blank. The following letters have a series of dots shown below them. Blank. Using a 2x3 grid and numbered 1 to 2, top row, 3 to 4, middle row, 5 to 6, bottom row.
But this is also no reflection on ASD. Accessibility is hard, very hard. Time pressures and unfamiliarity can all combine into creating digital experiences which are less than accessible or limit a certain demographic of user unintentionally. Mistakes like this can and do creep in. For the nation's top code breakers, progressively enhancing a complex image using Semantic HTML is a technique we can all take away for our digital projects. It's not perfect, but it provides more meaning to otherwise meaningless content. The power in the web is its adaptability. A content created with Semantic HTML means the content isn't only consumable visually, but audibly, as well as any other possible ways. And that's what Semantic HTML provides. Don't just make your content look good visually, make your content sound good and have meaning semantically. Thanks for listening. I'm Ross. I'm the director of CanAccess, a digital accessibility company based in Canberra. We work with lots of interesting teams around the world, helping them with accessibility audits, design reviews, WCAG conformance, and everything accessibility related in between. If you're interested in working together and making accessibility a tangible outcome in your digital projects, reach out to us at hello@canaccess.com.au. That's CANAXESS. Thank you.
Thank you very much.
Thank you. Oh.
Thank you very much. This is Steph from SSW TV signing out.